All right, everyone, let's go ahead and get started here today. Welcome to the Synology Partner Online Training. Once again, I'm Cody, and I'm going to be your guide on this webinar and many more to come after this as well. This webinar is going to be about SSDs and SSD caching, and the goal of this webinar is going to be really trying to give you guys some information about SSDs and how to choose this for your deployment, and really demystify some of the facts around SSDs so you can choose the correct one for your workload. And with that said, let's get into it. So on the agenda today, we're going to be focusing on three main categories. We're going to be talking a bit about SSDs versus mechanical drives, and will your workload benefit from SSD performance in general. We're also going to talk about all flash arrays versus flash caching and the best practices associated with those. And then finally, we're going to round out on choosing the right SSD and why enterprise SSDs are ideal for NAS devices, especially Synology devices in the data center and that kind of thing as well. So on the note of mechanical versus SSDs, we want to touch base on a few different categories here. One of them being the enterprise workload challenges that any enterprise admin faces. We're going to take a look at some facets that they have to take into consideration in terms of balancing different portions of the workload. We're also going to talk about the differences between mechanical and SSDs and why there's such a performance disparity between the two. And we're finally going to round out on some deployment considerations and some things you should take into account if you're deciding on whether to go with hard drives or going with an SSD cache or an array in general. So enterprise workload challenges, doesn't really matter what the workload is. It's going to be a balancing act of these three different facets of the workload, trying to achieve the lowest latency possible, the highest efficiency, and optimize system utilization. So low latency is really how quickly do the drives react to a query or anything like that. Also, the high efficiency is going to be about how quickly those drives do end up serving that data after they are contacted. And then lastly, optimized system utilization is really making sure you're utilizing the maximum performance possible with each device so you don't leave any performance on the table. So any workload in the enterprise space is going to be a balancing act of these three different categories here. When we talk about mechanical drives, of course, we're talking about moving parts in the device itself. You have different portions of the drive like the actuator, the read-write arm, spindles, and also the platters where your actual data is stored on the drive. So because we have these moving parts, you actually have a bottleneck because of seek time for this arm to read across the platters and things like that as well. With mechanical drives, you have a really high capacity. As we all know, this is going to be the most dense storage that's pretty much available to everyone. Right now, it goes up to 16 terabyte drives with larger sizes, of course, incoming. As hard drive manufacturers release additional capacity, you'll notice that Synology's capacity will also increase. So as you see 18 terabyte, 20 terabyte drives in the future, you'll see us get those on our compatibility list, and also you'll see our capacity increase with that. Another big thing about mechanical drives is that they're cost effective. As we know, you can get multiple terabytes for just a couple $100 nowadays. And so the cost per gigabyte is generally way less than 5 cents per gigabyte. So it's definitely a cost effective solution if budget is of a concern for your deployment. Solid state drives, on the other hand, have no moving parts. So of course, there's less opportunity for the drive to wear mechanically. There's no actuating arm, and there's no motors spinning up at all inside of the SSD. It's all electronic. So less chance of it wearing down in the same way that hard drives actually wear out. But you do have smaller capacity and a higher cost. If we take a look at enterprise SAS SSDs, many people know that those can cost many thousands of dollars per drive. And so that might be cost prohibitive in and of itself. You also get much higher performance with a solid state drive because the hardware bottleneck of the actuator and disk are virtually non-existent inside the solid state drive. So if you need to hit high performance numbers, solid state drives are always a great direction to go. So some trade-offs and considerations associated with choosing hard drives versus solid state drives. To achieve that low latency of those three categories that we're trying to balance in an enterprise workload, the traditional approach would be to add more hard drives, increasing the quantity of hard drives. So what's happening whenever you do that? You're spreading out the seek time across additional drives, and you're reducing the chance that there's a contiguous read or write on the same disk. So that's why in the past we would add more drives to an array so that you get lower latency. But the trade-off there is you have ballooning maintenance costs as you add more drives as well. So you have higher maintenance costs, space costs, hardware costs, all across the board. The costs are multiplied based on how many drives you add. But if you go with SSDs, you get high efficiency, but you lose some capacity because a lot of SSDs are not even close to the density of hard drives. They're definitely converging that way. But as it stands, most drives available today in the mainstream are not close to hard drives, max capacity. Along with that, SSDs have a really high resource efficiency with a large investment, of course. But what's great about this is that each SSD can be used to its full potential. That has, this is where the optimized system utilization comes in. If you have a lot of hard drives in the array to decrease your latency, then that means that each hard drive isn't actually utilized to its fullest potential in that case. So SSDs is going to allow you to actually utilize the max potential of that device by going with that solution if your budget allows for it. We're going to also touch here on all-flash arrays versus SSD caching. And in this category, we're going to talk about what does benefit from SSD caches, what doesn't benefit from SSD cache, and also the differences between an all-flash array versus a cache system. In terms of what does benefit from SSD caching, it's pretty much all file and block storage services. So anything like iSCSI or a file transfer service like SMB or something like that will benefit from SSD caching. On top of that, virtualization. Whenever you have a data store, your data store speeds are going to always benefit from some sort of SSD device inside of the system. So be that SSD caching or a full SSD array, virtualization definitely benefits from that increased I/O performance that you get with SSDs in general. On top of that, online transaction processing servers and other databases also benefit greatly from SSD caching. A little bit of history here. Synology actually designed this SSD cache implementation to specifically optimize database performance. So definitely if you are housing a database on the device, SSD cache is going to help with that as well. But you do need some sort of data access pattern. SSD cache works in such a way that it analyzes what data you're actually utilizing most often, and it migrates that onto the SSD cache. And if you don't have any kind of pattern, then the SSD cache is constantly trying to populate itself with your new frequently accessed data. So if it's completely random, it's constantly trying to populate the cache, and you're actually not getting any kind of additional performance from it. What you'll instead need to do if you have entirely random access is actually go with an all-flash array or just do a full flash volume because SSDs are pretty much designed for those random access situations. What doesn't benefit from SSD caching? Anything that has like a large sequential read or write, so HD video streaming or surveillance video recording where those video streams are coming in continuously, those do not benefit from SSD caching. Like I said, there's no pattern there associated with that because it's new video coming in constantly. So anything that is entirely random access, also since there's no pattern there, you'll want to go with an all-flash array or something like that to get the best performance possible. So what is the difference between all-flash arrays and SSD caching? Caching really unlocks performance of your hard drive array and adds a little bit of the speed that you get from SSDs on top of your storage that you already have. Whereas all-flash arrays are actually just pure performance since they have just only SSDs in them. All-flash arrays are designed for random access or any kind of I/O sensitive workload. So if you need a very fast data store, one of our large flash station units like the FS6400 is going to be able to handle quite a few virtual machines running off of its data store because of the speeds that you gain from the all-flash array. Also, again, caching needs a pattern where like a totally filled out all-flash array doesn't need a pattern at all. It can totally handle the random access associated with that as well. So really the difference between all-flash arrays and caching is supplemental to your array, whereas an all-flash array is a pure performance array for those high-speed workloads. So another thing we want to touch on is flash deployment considerations and talk about if your network is going to support your entire deployment. So we see a lot of people pushing to just drop a lot of SSDs into their devices and expecting to get maximum performance just with that in and of itself. But but you also need to have a strong network backbone to support all of that extra speed. So you can't expect to have a very large SSD array and have it run at its maximum potential on a single 1 gig connection. You'll need a little bit more network infrastructure to really leverage that. We're also going to talk about the cache and all-flash array RAID configuration options. So there's a couple different things you can do there. And with all-flash arrays in particular, there's a couple RAID options that will help increase the life or at least reduce the chance of a cascading failure on an all-flash array's RAID array. We're also going to talk about implementing SSD caching and some of the hardware considerations you should take into account when you're looking to do that on your system. So we're going to touch base on network thresholds here. So I wanted to prime this one real fast, is that the first two examples of these RAID arrays were done utilizing drives off the compatibility list for the RS1619XS Plus. And then the third one that we're going to look at is a SAS SSD array. It's just a 4-drive array, and these are drives that were pulled directly off the compatibility list for the SA3400. So some things to consider about your network. Theoretically, a 1 gigabit connection can have around 125 megabytes per second throughput and around 30K IOPS at the theoretical max. And obviously, a 10 gig connection is going to have 10 times that ability there. So if we take a look at 4 times hard drives in RAID 5, you don't get a very good IOPS reading in this case right here. Honestly, if you needed greater IOPS, you would add additional drives like we mentioned, or move to a different RAID type like RAID 10 or something like that. That would squeeze just a little bit more performance out, but not much, honestly. But you do get pretty good throughput on this RAID array right here at almost half a gig per second. As you can see, we have the 1 gig connection on the top there. It's at 125 megabytes per second. That single connection is not going to cut it on the throughput there. So what you're actually going to want to do is team about 4 of our NICs together, because a lot of our devices have 4 1 gig ports on the back. You could team those together and be able to serve out that throughput from that array right there. However, whenever we begin to move on to a SATA SSD array, and this is again 4 SSDs in RAID 5, for all of these examples, I did a 50% read and 50% write when we did these calculations. Before diving into this one, I wanted to note at 100% read on this calculation, you get the theoretical max IOPS is around 160,000. If you take a look at the IOPS readings or benchmark ratings for the RS1619XS Plus, its max 4K random reads are right around that theoretical maximum. So you can rest assured that you're not leaving any performance on the table by going with Synology. The device itself is not the bottleneck in almost all cases with us. So in this case, you can see that we have 50% read, 50% write. We have 80K IOPS and almost a gig of throughput. So as you can see, teaming just 4 of those NICs together wouldn't actually fully hit those throughput numbers. And likewise, you might be able to hit those IOPS numbers with 4 1 gig connections teamed, but this is 50% read, 50% write. So if this begins to skew towards read or write in this environment, then you would actually need a different kind of connection. You'd actually want to begin to move up to a 10G backbone, because your throughput can definitely be served from a single 10 gig connection, as well as your IOPS. So definitely at least one 10 gig connection whenever you start to have a SATA SSD array. In the case of a SAS SSD array, you can see that your performance skyrockets whenever you choose this solution. We're looking at over 300K IOPS and almost 3 gigs of throughput there. So you're going to actually want to team multiple of these NICs together, at least 3 if you're looking to hit those throughput numbers. And you'll probably actually want to end up teaming a couple more if you wanted more speed, or add in kind of a multi-path MPIO setup. You definitely would want more NICs in that case. So as you can see, you can't just drop in SSDs on a single 1 gig connection and expect to get its maximum performance. You're going to need to have the network infrastructure behind it to support that level of speed. So let's talk about the different cache RAID types and all flash array RAID types here. So the first one is the read-only cache. This is going to be something that you can create with 1 to 12 SSDs, and they can be mounted in either a basic or a RAID 0 configuration. So a lot of people will use this for document servers and that kind of thing, where they're just viewing the data. So it'll increase the performance of getting and reading files. Read-write is a little bit different. It's going to increase the performance of both read and write operations, obviously. This can be mounted in RAID 1, 5, or 6, and you can have up to 12 SSDs in that array. You're going to see read-write cache definitely function very well, as I mentioned in those database solutions. It'll help speed up those database queries. Along with that, there's a couple other packages we're going to look at a little bit later that also benefit from a read-write cache as well. The last RAID type I wanted to talk about is actually an all-flash array RAID type, and it's called RAID F1. And it's a proprietary RAID type that Synology created that is a derivative of RAID 5. And what is unique about it is it causes an uneven parity distribution to be written to different SSDs. So that one SSD will reach the end of its lifespan earlier than all of the others. So we've all heard of those horror stories where someone buys a new all-flash array, they buy all of the SSDs at the same time from the same batch, and they begin working on those SSDs right after they install it. There's definitely some stories out there where all of the SSDs reach their end of their lifespan at the same time. So whenever they go to rebuild the array, additional drives fail and that kind of thing. So that's why Synology created RAID F1, is to help mitigate against that. So that with this one SSD getting an uneven parity distribution, whenever that dies, you'll have enough time to replace that drive and fully rebuild the array without having any of those cascading failures that keep us up at night. So definitely, if you can, use RAID F1. But if you needed more parity bits, since it is a RAID 5 derivative, there's no problem going with RAID 10 or RAID 6. But RAID F1 has a little bit of protections in place in the event of a cascading failure. So let's talk about implementing a cache. So we have 3 different options for implementing a cache. So we have an M2 D18 card that is compatible with pretty much any unit that has a PCI slot, except for the SA series. And so what's great about the M2 D18 is it gives you 2 M2 slots on a PCIe card that you can then use for SSD caching. Some of our newer units have M2 slots built in directly to the motherboard, so you don't actually need to get the card. A couple examples of this are the DS918 Plus, 1019 Plus, as well as the RS1619XS Plus. So you can utilize SSD cache without needing any additional cards on those. That being said, you do not need to have an M2 D18 card or an M2 slot to do caching. All of our hard drive trays, those 3.5-inch form factor trays, have screw holes for SSDs directly on the tray. So you don't need any additional adapters to run SSDs directly in the front of the unit. So even if you don't have space for the M2 card, you're using an SA3400, or your PCI slots are filled with additional 10 gig NICs or something along those lines, you can still have an SSD cache utilizing one of the front drive bays right on the front of the unit. And one thing I wanted to note is that if you are planning to use a cache or you want to see if that'll work, make sure you budget for it ahead of time. You're not going to be buying your SSD cache drives prior to getting the unit. There's no one at Synology that can estimate what your cache needs to be over the phone or via email, because all of your workloads are completely unique. So that's why we created the Cache Advisor. Best practice is to get your device populated with your hard drives and put it into production without the cache in it first. After about a week or 2 of usage, we say run the SSD Cache Advisor inside of Storage Manager, and it will spit out the size of SSD cache that you need that you'll actually benefit from. So that way you'll have a high hit rate and that kind of thing on the cache, which it shows that you're getting the most benefit from the SSD cache and definitely optimizing that system utilization. So definitely it's best practice to get that unit in production, run the SSD Cache Advisor, and then follow its instructions for what cache size you need. So we're going to move into choosing the correct SSD here. And some different use cases for the SSDs in terms of Synology deployments. So we're going to talk about some specs to consider whenever we're talking about choosing an SSD, the difference between enterprise and consumer SSDs, and finally the use cases for caching utilizing Synology products and workflows. So some specs to consider are, the biggest one really is terabytes written versus drive writes per day. This is going to be a good indication of the level of endurance that your drive has. So consumer drives will have a very low terabytes written or drive writes per day. Drive writes per day can sometimes be way less than 1. And so you don't want to use those if you have a high, very intense workload in your environment, because you will chew through drives pretty quickly. So take these into account. You want to have probably a drive writes per day of definitely more than one if you're going to be using this in kind of a heavy workload environment. You also want to take a look at the type of flash memory. So the consumer grade flash architecture will be a little bit different than enterprise grade. So make sure you're not just getting the most basic form of flash memory. You want to go with something that is a little bit newer and a little bit higher grade. Some of the different ones like quad and that kind of thing sound like they're the biggest and best, but they're actually still a derivative of consumer flash memory types. So keep that in mind whenever you're looking at different types of flash drives. You also want to take into account the stated IOPS and sequential read ratings for the individual drives. So yes, this does mean you're going to need to look at the data sheets for any of the drives you are considering. All of our benchmarking, all of the tests that we did today in the network thresholds portion, that was done with a specific type of drive, and you should expect a similar level of performance with that specific drive. But if you choose a drive with less of an IOPS rating or less of a sequential read rating, you will ultimately get less performance. So you want to make sure that you're in line. If you want to hit the numbers that we have benchmarked, choose the SSD that we did, or choose one that has a higher rating for IOPS or sequential read ratings to maybe even get a little bit more performance out of the device itself. Last thing I wanted to touch on here is that we actually do all of our benchmarking in SATA. So even on the SA3400, that was benchmarked as a SATA drive, with a SATA drive. So if you do go with SAS on that device, you will actually see more performance than what we actually benchmarked. You might actually see some higher IOPS ratings because of that's just the nature of SAS drives themselves. So keep that in mind whenever you're looking at the benchmarks as well. So let's take a look at some performance in real time of enterprise versus consumer drives. So as you can see from these couple graphs here, at first glance, you're going to say, wow, this consumer drive has a lot of performance. It's on almost a completely different scale than the enterprise SSD one. And to a point, you're right. It has some very high peaks up to 140K IOPS, whereas the enterprise SSD is hovering right around 35K. But as you can see, there's lots of valleys for the consumer SSD. It does not have very consistent speeds whatsoever. And the distance between the peaks is also much wider for the consumer SSD versus the enterprise SSD. And if you look at the graph, the consumer SSD is actually hitting zero pretty frequently inside of its operation space here in the term of about 1,200 seconds. So this bodes poorly for any kind of enterprise workload. You don't want variability in your storage array. You want consistency in your storage array. So that's why you would want to go with an enterprise SSD in Synology NAS devices, or any one of your data center devices for that matter, because you can get predictable speed that allows you to build your solution perfectly because of that. Because if you have a predictable speed, then you can easily spec out your system. So as you can see, the enterprise SSD actually never goes to zero in the course of this entire operation. So keep that in mind whenever you're choosing your SSDs. Enterprise drives are in a different league than consumer drives completely. So let's talk about some different features of enterprise versus consumer drives. The first big one is over provisioning. So SSDs have a limited program erase cycle. So SSDs don't have an overwrite feature. You actually have to erase the block and then write back over it. So they have a limited amount of those operations available to it over its lifespan. So over provisioning is created to kind of increase your SSD's lifespan. And so the two methods that it does that through is through garbage collection as well as wear leveling. Garbage collection is where valid block pages, which pages are like the smallest portion of the block that can be written to. Valid block pages are moved to free blocks while erasing blocks with invalid pages. And also wear leveling is an algorithm that spreads out write/erase operations evenly among blocks. And it does so by swapping out frequently used blocks with free blocks to equalize the amount of usage on those. So in that case, each block has an equal wear pattern across the entire SSD. So the reason why over provisioning is there and all that, and why you see how enterprise SSDs don't actually hit even numbers for their storage, it's like 3.84 for a 4 terabyte drive, is because both of these methods require storage space on the SSD to function. Over provisioning is really the partitioning of the space for use by the SSD storage controller to clean up these different facets of its operation. The next big thing here is enterprise SSD capacitors. So enterprise SSDs have capacitors on their chip there. And so what's significant about this is when you're using SSDs and the power goes out, you want to make sure that you have something in place to have the SSD purge whatever data it was writing to it before the power goes out. And that's what the capacitors are for. If you lose power, it's going to purge what's in its cache internally on the device so you don't lose any data. Along that same vein, if you're using enterprise SSDs, you have capacitors. But if you're using a read-write cache with us, it is best practice to use a UPS battery backup so that if you're using that read-write cache and there is a power outage, it'll purge things out of that read-write cache so you don't lose data. So please use a UPS if you are using SSD caching, read-write cache especially. Also, with consumer drives, as I mentioned, they're typically less than 1 drive write per day. And so if you have a really heavy workload, you're going to chew through those drives pretty quickly, whereas enterprise drives will have very many drive writes per day available to it over the entire course of its life. So that all translates to a greater amount of terabytes written to enterprise drives versus consumer drives. So in the interest of not constantly replacing your drives, definitely go with enterprise drives whenever you have an intense workload. So here are some use cases for SSDs and caching. As we mentioned a little bit earlier, business file servers and document libraries benefit from a read cache. So these are the type of file servers that the data isn't actually being changed by the end user. They're actually just taking a look at files. Maybe they're HR documents, schedules, things like that. So a business file server that's really just a big repository of frequently accessed files would benefit from a read cache. Now, Synology High Availability, if you actually take a look at its white paper that we have available online, you're going to see that it does mention that it does benefit from a read-write cache. So one of those things that I wanted to mention is that if you're going to do a Synology High Availability and you're going to put a cache on it, you have to make sure that you have an identical cache on both devices, just like you would have identical RAM, identical drives, identical network infrastructure for the device. You would have to do that for the cache as well. But what it really helps with is the heartbeat and syncing procedures that you see with Synology High Availability. So read-write cache will increase the performance of those syncing features as well. So definitely go with that if you're going to go with high availability. The other big one where read-write cache definitely helps is mail servers or databases in general. As I mentioned earlier, our SSD caching implementation was developed to optimize database performance on our devices. So use a read-write cache if you're housing a database, or go with an all-flash array if the database has a very high hit rate. Mail servers benefit pretty well from this as well, especially since mail servers are definitely a lot of reread operations. They'll benefit from a read cache and a read-write cache for that matter. So any kind of mail servers, databases, online transaction processing will all benefit from a read-write cache. Now, this next example is a little bit of a niche situation here, but if you are a multimedia post-production office and you have multiple editors looking to edit off of the NAS at the same time, go with SSDs because you need that increased performance. And as we saw on the network threshold slide, you want to also have a 10G backbone as well. Otherwise, you're not going to be getting the greatest performance off of just hard drives and splitting it up across multiple users editing at the same time. You'll want to have the ability to run off of those SSDs and use that 10G connection so that you can actually hit those throughput and IOPS numbers we took a look at a little bit earlier. So another thing I wanted to note is that it is best practice to have a production NAS that you're editing off of the SSD volume on that NAS and have a completely separate unit for archive. A lot of people try and mash them all together, but it is always best practice to have your archive on a different device because your editing suite might be pretty crowded, or they might have drinks near the NAS or something like that, and things happen. So you don't want your archive to be on your main production editing device, because if that goes down, then you also lose your archive until you can rebuild that unit. So definitely have a secondary unit for archive if you're in multimedia post-production.